So I get that talk that's going to sound very negative because I'm going to focus just on climate change itself and not, what all the things we can be doing about it, both in terms of adaptation and mitigation. I'm going to base this on two different assessments that came out recently. One is the IPCC assessment. If you've seen the new report, it's the first working group, which is the one I'm on, the science of climate change. The report is this thick. And there is a policymaker summary, which is much more straightforward to understand. Many authors, extensive review, analyses, et cetera. Similar kind of thing for the National Climate Assessment. Oops, pointing this in the wrong direction. The National Climate Assessment, this is the third assessment that just came out. We presented it at the White House in May. It's based on a law that was signed in 1990. It was supposed to be every 4 years because of various complications, mostly government forgetting. This is actually the third assessment. We are now trying to do it every 4 years. The last one was 2009, and we would have published this assessment in late last year if it hadn't been for the government shutdown. This assessment is the most comprehensive analysis ever of how climate change is affecting our nation now and how it could affect it in the future. And we could say a very similar thing about the global impacts if we look at the IPCC assessment. So I invite you all to go to this website. I had hoped to have some copies of the highlights here. The hotel can find the ones that were delivered for me this morning. We're trying to see if we can get them sent over here. And if they make it, then there'll be some copies of the highlights for you. That's about 140 pages. The full assessment is on the web, and it's 870 pages. But what it does do is look at each region in detail, plus each sector of society, and whether your interest or water, energy, transportation, agriculture, whatever, you will find chapters relating to that. In fact, one of the heads of our agricultural chapter is right here. He's going to be giving a talk a little later. From both of these assessments, we can say that climate change, human-induced climate change, has moved firmly into the present. We're feeling the impacts now. The changes in climate we're seeing are about 10 times faster than occur naturally based on analyses of data since the end of the last ice age. Human activities are the primary cause, particularly of the changes we've seen over the last 50 years. Now, in changing machines, somehow this got distorted, so you can't see the roughly 1.5 degree increase in temperature we've seen over the last 100 plus years. Most of that change coming in the last 60 years, which is the time period when natural forcings on climate cannot explain that change at all. We'll talk a little bit more about that later. But if you take that temperature change, which you can barely see, if at all, from the left, and then transfer it to the right in terms of looking at over the last 2,000 years, you find that the recent changes are way beyond the normal. In fact, the last decade, as we'll talk about in a minute, it's likely the warmest decade over that entire time period. And we could talk about details of that. You can see the medieval warm period in the past temperature analysis for the Northern Hemisphere. You can see the Little Ice Age, when it was extremely cold in Europe and North America. But no period that, at least going back this time, and probably much longer, do we see anything approaching the temperatures we have now. Now, climate change isn't just temperature. It's many, many other variables. We'll talk a little bit about precipitation, changes in severe weather, et cetera, as we go through this. But there are other indicators that the climate is changing. So if we look at For example, what's happening to sea ice in the Arctic, we find that it is greatly decreased over the last 40, 50 years compared to what it once was. That doesn't mean every year it's down. It really depends on the local weather. But so this is just looking at area. Now, if we were to look at the volume of ice, which we can actually get by using two different satellites together, we can actually determine the volume of the ice. You find the ice volume is actually decreasing year by year. There's a recent report about ice found where it's never been found before, and you see some of the Niosphere saying that, oh, that just shows you there's no climate change. Well, that's just because some winds blew some ice into some area that normally doesn't have ice at all. But that's, one could also associate those wind changes with what's happening in the climate system. In addition, glaciers throughout the world are decreasing well over 90% of the glaciers. For someone from Wyoming and Montana, you'll find that glaciers generally are decreasing throughout the world. I took my wife to Glacier National Park a couple years ago for our 40th wedding anniversary, and the people there, which are also very conservative politically, know that something's happening because their glaciers are disappearing. And in fact, out of the 125 glaciers they had less than a century ago, they have 25 left, and it's decreasing year by year by year. Greenland and Antarctica are losing ice as well, much more than we thought it would be by this point. But that is also occurring. This just shows the amounts of loss in terms of gigatons per year. Now, going back to that temperature record, this last 5 decades, we've seen an increase in temperature decade by decade, and this last decade was the warmest in at least the last 150 years when we've had these surface measurements of temperature. But using those proxies I showed you earlier, we can actually go back much further, probably about more like 1,400 to 2,000 years, at least. Temperature on the global map shows that, and the oranges, reds, and purples here are all increases in temperature. The blues are decreases. Most of the planet, and in white, is where we don't have enough measurements to clearly draw it in this map, because we're looking at 1901 to 2012 here. We've seen a significant change in temperatures throughout most of the world. The only exceptions actually are in some parts of the southeast U.S., where it isn't exactly known why that has occurred. It's due to somewhat in circulation patterns, but also perhaps related to deforestation that occurred early in the century, and reforestation has occurred since. But also you see a cooling in the region where all this fresh water is coming into the Atlantic Ocean off of the melting in the Arctic, and also from Greenland. Otherwise, you see very significant changes. The largest changes are on the land masses, and particularly at higher latitudes, and there's good reasons for both. The oceans have a large heat capacity, and at high latitudes, we have what's called the ice albedo feedback. That is, the ice decreases, the reflectivity of the Earth decreases, and we absorb more energy, and we end up warming that region even more than the equatorial regions. Similar for the U.S., we also have seen a significant change. This is looking at the period of 1991 to 2011 relative to 1901 to 1960. Again, warming throughout almost the entire U.S. except for a small part of the southeast. And generally an increase comparable to the global one, about 1.5 degrees Fahrenheit. Also, we're seeing an increase in the frost-free season, the season between when we don't have a frost. And so essentially this is an indication that the growing season is lengthening throughout most of the country, particularly in the western part of the U.S., but even over a week here. Precipitation in much of the U.S., particularly northeast and Midwest, has increased. The west and southeast have seen some regions with a decrease, and particularly overall, except for today, when we got the large monsoon coming into Arizona, that region has generally been in a drought conditions for well over a decade now. In addition to these kind of average changes in temperature and precipitation, much more important actually to humanity and impacts on humans and ecosystems are the concerns about severe weather and what happens with severe events. We're seeing very strong trends about severe weather. We're seeing more heat waves generally across the U.S. Not every place, actually the Midwest isn't showing that same trend. And those heat waves will likely become longer and more severe, and that'll be true of the Midwest as well. Cold waves across the nation are decreasing. Doesn't mean we don't occasionally have a cold wave. We do, and we had certainly had a cold wave this past winter here in this region, but generally across the U.S. they're decreasing. And again, we're looking at climate timescales, not weather timescales, so we're talking about periods of 20, 30-year averages and statistics of weather, because we're trying to look at the big scale kind of things, which I don't want to get off into the weather versus climate thing, but it's actually somewhat easier to project what climate will be like than it is weather, where we can only go out less than 2 weeks for forecast, even at the best. And right now we're not even at 2 weeks. More precipitation is coming as larger events. We're seeing a very strong trend across most of the country when it does rain or it does snow, that you're likely to get a much larger event. That's not surprising. The basic physics is that a warmer atmosphere can hold more water vapor. And so as you get the right kind of synoptic conditions for a storm, you're likely to dump more water vapor, and that is exactly what's occurring over much of the country. Increasing risk of floods as a result in some regions, particularly the Northeast and Northwest, which has seen the largest increase generally in precipitation, and droughts are increasing in some regions, particularly the Southwest and the Southeast. We're seeing an increasing tendency for hurricanes in the Atlantic, no clear signal yet in the Pacific, and those trends are likely to continue with particularly in terms of the intensity of these storms, and these trends generally for all these different types of events are likely to continue. I don't have strong statistics on other types of thunderstorm, large storm type events in terms of tornadoes, hail, ice storms. We're actually working hard on that. Generally, we think that there will be a tendency towards more intensity in those storms, but we don't have all the published results. The nation knows that we are actually having more concerns about severe weather. If you look at the U.S. billion-dollar events, which NOAA has been tracking since 1980, you've generally seen over the recent years a strong increase in the number of such events and also in the cost to our nation, with recent years being well over $60 billion a year, over $100 billion a year most of the recent years. And these include droughts, heat waves, hurricanes, winter storms, crop freezes, local storms, wildfires, and flooding. I mentioned the increase in precipitation, more precipitation coming as large events. That's happening throughout most of the country, with the exception being Hawaii. And this is only because we included the most recent year. If we had left out the most recent year, actually Hawaii had a slight increase, but they've had a very significant decrease in large precipitation in recent years in Hawaii. And so it really shows up when you do the statistical analysis. But this is looking at the top 1% of rainfall in each location around the country, and it's looking at it by region. So we've broken the U.S. up into the regions that were used in the National Climate Assessment. Particularly the Midwest and the Northeast have seen a very significant increase in precipitation coming as large events. Well, all of this is related to the greenhouse effect and the fact that human activities are changing that natural effect. We wouldn't be here without the greenhouse effect. This would be a frozen planet. And we are affecting that by adding carbon dioxide to the atmosphere. We know that there's natural drivers of climate change. It's not the sun causing this. The sun has actually decreased in intensity over recent decades, last 4 or 5 decades. And everything matches up well that what we're seeing is related to the increase in carbon dioxide, methane, nitrous oxide, what are all called greenhouse gases that can have an effect on the climate system. Amount of carbon dioxide in the atmosphere has increased to current concentrations of 400 parts per million. Very tiny amount in the atmosphere, but it's very important to our climate system. And in fact, we have not seen such levels on our planet until about 1.5 million years ago, when it was much, much warmer than it is currently. And that was due to outgassing from volcanoes. Whereas what's happening now, this increase in CO2 is almost entirely related to either changes in land use or burning of fossil fuels. Burning of fossil fuels accounting for the vast majority of that change. If you looked at the period from 1951 to 2010, the observed change is about 0.6 to 0.7. The natural or the human-related forcing would be slightly bigger than that from those gases, but it's compensated by some cooling effect from particles that we also put into the atmosphere. And the net effect is that we can fully explain this temperature change because of human activities, whereas solar changes cannot explain it at all. There's been very little change, in fact, as I mentioned, mostly negative, and an internal variability in the climate system also cannot explain this. Now we can look at shorter time periods and we could see natural variability being important. And we could get into that, but I don't have time to. Extremely likely that human influences have been the dominant cause of the observed warming since the mid-20th century. We could also do other types of analysis of attribution, for example, looking at every part of the world and saying, well, how well can you explain the temperature changes we've seen there versus natural versus human causes? And the conclusion is that human influence on the climate system is clear. Ocean warming has dominated the increase in energy in the climate system. And in fact, the atmospheric portion of this is tiny. So what's going into the oceans is really important and also affects, therefore, what's happening in the atmosphere. Ocean cycles can be extremely important. In the long run, we're seeing projections of changes of as much as, this is for the US, but globally it's similar, 10, 11 degrees Fahrenheit increases in temperature if we continue the pathway we're doing now of heavily using fossil fuels. We can choose to be in a much lower path. All but that very lowest kind of light blue path are business as usual, where business as usual allows for the fact that not only is population increasing, but that we might choose to naturally might choose just to move away from the use of fossil fuels and thereby reduce the amount of carbon dioxide in the future atmosphere and what that means. The light blue one implies very major draconian moves to try to do something about climate to keep the temperature change down to a minimum. Looking at a lower case and kind of a lower middle case here, not that very, very lowest one, we see that the changes in the US are, in terms of temperature, quite large, the high case being as large as 10, 11, 12 degrees Fahrenheit average temperature. Rainfall is also likely to increase throughout most of the US. I'll finish it very shortly. Particularly in winter, spring, and fall, or particularly in our region, in Midwest and Northeast. If we look at the Southeast and the Southwest, though, we get a very different signal where it's likely to be drier in many of those seasons. And even here in the Midwest, throughout most of the country, drier summers. To give you a feeling for this, the Illinois summers are likely to become more like western or eastern Texas by the end of the century in terms of temperature and precipitation, and that implies a very different climate than we're used to here in Illinois. And I have stories about how this was presented for the Senate, but we'll go into that later. Sea level rise, we've already seen 8 inches increase, and that's likely to continue 1 to 4 feet over this century, in part depending on which of those pathways we follow in terms of scenarios. We easily could be at a situation by the end of the century where we're talking about the location where the keys used to be located. It really is potentially very dangerous to certain parts of the coastal areas, and particularly, especially the East Coast. At the same time as the amount of CO2 emissions are occurring, that's leading to the oceans becoming more acidic, and that is affecting life in the ocean, and particularly shellfish. And we're not really clear what the ramifications of this are likely to be over the century. About 25% of the CO2 ends up in the ocean. The impacts from all this, and I'm not going to get into impacts or solutions today, are very apparent in every region of the U.S. and is important sectors including health, water, agriculture, energy, and more. And if you want to see more about the assessment, there's the website from the National Climate Assessment, and I'd also be happy to point you to the IPCC assessment. Thank you.